Hello everyone. In this video we're going to see how you can use S-Concrete to design a wall concrete section using Code 2 with the Spanish National Annex. So we're going to begin here with S-Concrete's default interface. Here we have the different beams, columns and walls that we can design with S-Concrete. But right now we're going to open a new file by clicking the new file icon, where we can specify first of all the building standard. Like I mentioned, we're going to go with the Code 2 for the Spain National Annex. We're going to switch our units from imperial to metric. At the var type, we're going to set it directly to European, and like I mentioned, we're going to be working with a wall. I'm going to click here on OK, and as you can see, we have now this rectangular wall that we want to work with. So the first thing that I'm going to go and change in this iteration are the loads. So we have certain loads that we have per default in S-Concrete. We have the option to clear these right away to input our own loads. But what I want to do right now is just to increase the moments in here because of the subdue loads that we're going to have. So I am going to increase my moments on both directions, Y and Z, and then click on OK. So as you can see, this moment utilization has gone up all the way to 600%. So what we have here, it's a 6 meter long wall, but I also want to make this a little bit slimmer on the length side. So I can go here to my section dialog icon, and I can set these to 4 meters instead of the current 6 that we have. And I also want to change the orientation from 0 to 90 degrees. Now, because of the forces, the moments that I have, I know that probably it's not going to be enough with just the panel that I have. So instead of working with a rectangular wall, I'm going to go ahead and work with an I section wall. Now I have the option to increase my thicknesses of each one of the zones here. I can do this input directly from here or by clicking and dragging, which we will see in a moment. Now, here I have the option to specify my clear cover, my minimum moments, my slenderness effects if I so want. The miscellaneous have already been set in the first couple minutes. So I can also switch my material properties. These are set by the Code 2. So these are the standards for Code: 35 MPa for concrete strength, 500 MPa for the steel in both the vertical and the horizontal way. Now I'm going to click here on OK, and as you can see, this panel has changed the orientation and everything. Now the utilization ratio has one more time gone up due to the factors of the geometry and the loads, correct? Now I can go ahead and add some reinforcement to decrease this utilization. So I'm going to go here to my wall reinforcing dialog, where I have two options: my zone reinforcing, which are the zone A and zone B, and my panel reinforcement, which is what we have here in the middle. So I can first of all activate my zone reinforcement and select the different angle, the different bar size, and the different tie bar size as well. I can also select a different splice type for this, and pay attention that I can also apply my reduced maximum link spacing for the Code 2 clause 9.5.3. So I'm going to apply this one as well. Then I'm going to click here on OK. And as you can see, the zone reinforcement has been applied, but our utilization has gone down from 12 to 6. But it still is not where we want it to be. We can take a look at that if we go to the report, and we can see that we have a summary here of our building standards. Here, the Code 2 design of concrete structures for the Spanish Annex that it's rehearsing here. and we have all of the dimensions, the summary, and if we scroll down, we will see that, of course, our n versus m results are not acceptable, and if we scroll even further, we will get some messages about the panel reinforcement as well. So as you can see, we have a couple of messages, and there is one way that we can get closer to our best result, which is by running an automated design. So we go here to run and design constraints, where we can specify what parameters are we going to tell the software to move and what to stay frozen. So for example, I don't want S-Concrete to play around with the material properties. I want everything to stay frozen as it is. And I also, if I wanted, I could specify my wall dimensions and my zone reinforcement. So let's freeze the wall dimensions and see what it goes and do with the panel reinforcement and the zone reinforcement. Click on OK and then go to my automated design. I can do this step by step, or just click here on auto and let S-Concrete do what it does. Now I can see that it changed the vertical bars and the ties, also the type of splice, and it greatly reduced the n versus m utilization down to 1.6. However, we are still not passing the code check. So one thing that I believe will help is by increasing the thickness of these zones. So I can just click here and drag the zones to increase the size of it, and as you can see, this has reduced greatly the utilization. If I go and do it just a bit more, I get now a passing code check. So I can verify this by going to results, report, and now I get all of these passing code checks, and I can verify just what is happening here, that the only thing that is still not working is the area of a zone still. So we are over the top with this. So what I can do is reduce these verticals and amplify these zones as well. And now with those incrementations on the zones and the decrease of the area of steel, I have a passing code check with my n versus m utilization approved, and we have now no more code checks that are not passing. We have a clean design that will allow us to comply with the Error Code 2 for the National Spanish Annex.